بسم الله الرحمن الرحيم. الحمد لله رب العالمين والصلاة والسلام على رسول الله سيدنا محمد وعلى آله وصحبه وسلم أجمعين. أما بعد، اللهم علمنا وانفعنا وفعلنا علمتنا، اللهم إنك أنت العليم الحكيم. إيوه فارس، إيش بغيت تقول؟
لا بس بغيت أسأل إذا هي مسجلة ولا لا، بس طلعت مسجلة. يعطيك العافية.
الله يعافيك إن شاء الله. إي نعم، إي نعم. أوكي. أوكي شباب. Before I start, I have to check something. طيب. Okay, good. Okay, yeah. Welcome everyone to the help session of Math 101, where we're gonna make a first exam revision for the whole material from section 2.2 to 2.8. Okay. And today is Saturday, of course, 2nd October. I skipped section 2.1 because that section is introduction to the concept of the slope of tangent line and also to the concept of the limits. But then this concept later on developed and you learn a new tools, how to calculate the slope of the tangent line, how to calculate the limits themselves. Okay. I selected some problems for each section, from section 2.2 until section 2.8, where I feel these are very, let's say, most important problems and ideas in this course. But of course, I'm not covering everything, because I cannot cover like 4 weeks or 5 weeks material into 1 hour and 10 minutes. Okay? So, but I try my best to let's summarize all the ideas and revise all what we learn into this session. طيب يا شباب. So the first question, and by the way, this PowerPoint slide is already in the Teams folder, so you can go there and download. Except there is one slide I noticed I mistaken in one problem, so I corrected. This is the after the session I will upload the corrected one there. Okay. The question says evaluate the limit if it exists, and I have the limit this way. طيب يا شباب. What is the first thing I have to think or to check when I deal with the limits? The first thing I have to do is substitute. Substitute what? Substitute x equals 2. When I substitute x equals 2, here it will be 4 minus 4 over 4 minus 8 plus 4. But this will give me 0 over, and in fact here 0. So I have the expression 0 over 0. And 0 over 0, I'll put question mark to that one, because I don't know what this will give me. Because in some cases this will give you constant, some cases it will lead to constant number, some cases it will lead you to positive infinity, in some cases it leads you to negative infinity. We have examples actually in each one of them. But what we can do now to treat this 0 over 0 is to simplify the limit that I have. So now I have the limit as x approaching to 2 from the left, x square minus 2x over x square minus 4x plus 4. What I can do, it depends on the nature of the expression that I have. Now the nature here is a rational function. I have polynomial over polynomial. So what should I do here, Shabam? If I'm dealing with this expression, raise your hand if you know. Oh. Yes, Osama? Yes, Osama?
Common factor.
Common factor. So factorize each the numerator and denominator. So here when I factorize, I have x minus 2. Down here you notice that this is the complete square. So this is x minus 2 all square. And this guy will go with this guy. So we have limit as x approaching to 2 from the left. You have x over x minus 2. Okay. Now, but still, when I substitute 2, I will get 2 over, when I sub x by 2, so I get 2 over 2 minus 2, I got 0. Okay. Now, let me quickly go over this over 0 thing. Okay, this over 0 thing. Okay? And this is kind of revision, so we can judge what will be the next step after this. Do you know the limit of x approaching to 0 of 1 over x? If I said limit as x approaching to 0 from the right of 1 over x, what will it be? Well, you've seen this in the lecture, the graph of 1 over x, right? So this is x, this is y. If you want to graph 1 over x, it will be like this, and it will be like this, right? This is y equal 1 over x. When I approach x to 0 from the right, the values of this function will go to plus infinity. And similarly, when I take the limit as x approaching to 0 from the left of 1 over x, the values when I approach to this direction, the value of the function goes to negative infinity. So in summarizing these two, you can say that whenever I have a constant over 0, because I can put here 0, if it is 0 plus, then I have two situations. When I divide by 0, and that denominator is approaching to 0 from the right, this will be either plus infinity or minus infinity. But how I can judge if the constant is positive or negative? If the constant is positive, then I will go to positive infinity. If the constant is negative, I'll go to negative infinity. The same thing, if you have constant or 0 from the left, also it will be either negative infinity or plus infinity. It depends on the sign of the constant. Because when I go to 1 over 0 negative, it's like 1 over x when x approaches to 0 from the left, you have negative infinity. And then it will stay negative infinity if the constant is positive, or it will be positive infinity if the constant is negative. Now, back to our problem. Now, I am x approaching to 2 from the left. X approaching to 2 from the left. Huh? When x approaches to 2 from the left. Okay? If you look at the real line numbers, okay, this is a 2. I'm approaching from the left. Here, I am here. So what will be x minus 2? What will be the sign of this? Is it positive or negative, Isabel?
Negative.
Negative. So that means when x approaches to 2 from the left, this expression will be negative. But it will get closer to the 0. So that means I'm getting closer to 0 from the left. Okay? I'm getting closer to 0 from the left. طيب يا شباب. Now, 1 over 0 from the left is like 1 over x when x approaches 0 from, which is negative infinity. And the constant 2 is positive, so that means it will be negative infinity. It will be negative infinity. Okay? So the limit of this expression is negative infinity. Okay? Negative infinity. طيب. If I change the limit x approaching to 2 from the right, everything will stay the same except here that I will say 2 over 0 approaching from the right, because when I 2 approaching from the right, I'm getting numbers greater than 2. That means x minus 2 will be positive. That means I'm getting closer to 0, but from the right, that the answer will be positive infinity. Okay, if the question is about limit as x approaching to 2 from the right. Okay. طيب, any question here? Okay, so let's go to the next. Now find the limit of this expression when x approaching to 2 from the right. But now this is different from the previous one. So okay. So we're gonna say the following. Limit as x approaching to 2 from the right, x squared minus 2x minus 8 over x squared minus 5x plus 6, which is equal to the limit as x approaching to 2. What should I do? Well, when I substitute, I get 4 minus 8. If I try to substitute this guy, what will be? And just if you try to substitute in the right hand side, it will be 4 minus 8 over 4 minus 10 plus 6. So you get minus 8 over 0, right? So that means it's either plus infinity or negative infinity. Why I'm saying this? Because I am in the direction. I have a direction to 2, so I can tell which is 0 from the right or 0 from the left. But to make a clear picture on the denominator, I have to carry out, I will say this is limit as x approaching to 2 from the right. I have to simplify the expression. So this will be x and x. What will be يا شباب? x minus 4, x plus 2, and this will be x minus 2, x minus 3, right? So that you can factorize the numerator and denominator, but you notice that there is no cancellation going on. So what I will do, I will substitute. When I substitute 2, this will become negative 2. When I substitute here, it will be 4. When I substitute here, I have 0. When I substitute here, I have negative 1. Now notice I have 0 in the denominator. Now it's clear to me that 0 is coming from this factor. Okay, when I'm x approaching to 2 from the right, and I draw real numbers, I am here. So that means x minus 2 will be positive. And this will be positive, meaning that I am getting to 0 from the right. Keep in mind, x minus 2 is approaching to 0 anyway. When x approaching to 2, this will go 0 anyway. But I want to know, is it I'm coming to 0 from the right or 0 from the left? I know that I'm coming to 0 from the right. So this means that I can take 0 down, and when I multiply these numbers, I will get 8, right? Exactly. 8 over 0 from the right, this is like 1 over x as x approaching from the right, and 8 is positive. This becomes positive infinity. Positive infinity. Okay? Right. Yes, Faisal?
Doctor, why didn't make it minus 8? Shouldn't be minus 8?
Minus 8 over minus 1.
Oh, okay.
So it will be 8. Okay? It will be 8. So, any other question? Right. Okay. So the first two limits are going to infinity. I can leave this question to you because also it is the same idea. When I put here 5, it will be e of negative 5, which is a constant, not 0. But when you put 5 in the denominator, it becomes 0, right? So so you have e negative 5 over 0, and then you have 5 from the left. You can guess what the limit you will get. Okay, who can tell me what will be the limit of this one quickly? Cube, يا شباب, it doesn't change. If x minus 5 is negative, the cube will make it negative. So is it positive infinity or minus infinity, شباب? You know, raise your hand. Just يا عبد العزيز.
It's minus infinity.
Minus infinity. Very good. It will be minus infinity. Okay, so we skip this one. Yeah, let's go to the next question. Find the equation of the horizontal and vertical asymptote of each curve. Okay, so the first curve I have is this coming from this function, f of x equal these guys. Okay, so while I type this, who gonna remind me how to find, for example, the horizontal asymptote? How to find the horizontal asymptote? Okay. Yes, Abdulaziz.
Yes, I think I have the actually idea that limit when x approaches to infinity, so we divide by the quotient to the highest power.
So the concept, the main concept is to take the limit as x goes to infinity, and then another step, I will take the limit as x goes to negative infinity. Okay. So let's start with limit as x goes to infinity of the function. If I get at the end, if I get a constant, then I have the horizontal asymptote. If wallahi at the end I get something does not exist, for example, plus infinity or minus infinity, then I will say I don't have a horizontal asymptote. Okay. So let's try this guy, the limit as x approaching to infinity, and let's put the function here, which is x squared plus 2x plus 1 over x squared plus 3x plus 2. Now, in section, if I'm not mistaken, I think in section 2.6, the limits at infinity. When you have a polynomial over polynomial, we said that when x goes to infinity, I will look for, I think Abdulaziz said it, he said it, we look for the highest power here, right, or highest degree. So I have x squared, and here I have x squared. When the degree of the polynomial in the numerator is equal to the degree of the polynomial denominator, which is the case I'm having here, then the limit will be the coefficient of this guy over the coefficient of this guy, the coefficient of the leading term. So this will be equal to 1, because the coefficient here is 1, over 1. So here you have 1. So now I have a horizontal asymptote. And if I check the limit as x goes to negative infinity of the same function, it will be the same thing. You will get 1, okay? Because here you have x squared. When you put negative numbers, still you get positive theta, so you get equal 1. So from these two things, you can say that how I can express a horizontal asymptote, Shabab? What should I write here?
Y is equal 1.
Y equals 1 is a horizontal asymptote. I'm just making sure. HA means horizontal asymptote. And this is a common mistake between students. Some students, they say 1 is a horizontal asymptote, which is not correct. You must say Y equals 1 is a, because Y equals 1 is the equation. Is equation of a horizontal line. But this line is special for that function, which is a horizontal asymptote. Now let's just look for vertical asymptotes. Let's look for the vertical asymptotes. To look for the vertical asymptotes, well, we have to look into the function over x squared plus 3x plus 2. And remember, it is to look, search for values of x that where the function, this is the idea. I will search for values of a here. I put it here. When I take the limit, it will be either plus infinity or minus infinity. Okay? It will be either this or this. I have to look for a. And this a, it depends on the nature of your function. You have to look for where are the points where the function will blow to infinity or blow to negative infinity. Okay? I mean blow in the sense of the values or the curve itself. Okay? So for a rational function, the suspects will be in the denominator. I will look for the zeros of the denominator, because the nature of the rational functions or any fraction, you look for the denominators, right? So to get the values in the denominators, I have to factorize. So this will be factorization will lead to x plus 2 and x plus 1, right? And here up, you notice this is a complete square, so it is x plus 1 square, or you can say x plus 1 times x plus 1. But be careful. You have two potential, two suspect values. It's either x equal negative 2 or x equal negative 1, right? So it could be this and this. I have to check. I don't rush and judge and say these are the vertical asymptotes. I have to be careful. But notice x plus 1, it can be cancelled by x plus 1, right? It can be cancelled by x plus 1. So I can say this is equal x plus 1 over x plus 2, such that, I have to write this, such that x is not equal to negative 1. Okay? Not equal to negative 1. So you see now I have only one suspect, really suspect to be a vertical asymptote, which is x equal negative 2. That will make this 0. And notice the denominator is not 0, x equal negative 2. But of course I have to write the limit. So this will be here. Okay. So now the limit when x approaching 2, negative 2 of f of x is equal the limit when x approaching to negative 2 of this expression, which is reduces to this expression, and not and remember when I say except negative 1, because I'm working close to negative 2, so I'm away from negative 1. Okay, and here what will be when I substitute negative 2 in the denominator, so I get negative 1 over 0. But here I don't have any judgment here, because if the limit like this, I would say it does not exist. I'll say it does not exist because it differs from the right and the left for this situation. But to fix this, I have to choose a direction of my limit. Should I go from the right or should I go from the left? And here is up to you, actually, because I need at the end either plus or minus infinity. So let's say I'm coming negative 2 from, let's say from the right, okay? And from the right. So when I come from the right, this is negative 2, this is negative 1, this is negative 3, I'm coming from here. So when I say x plus 2, ya shabab, what will be the sign of this? Is it positive or negative? So it will be, yes, shabab, anyone?
Positive.
Positive. So this will be 0 positive. When 0 positive, meaning that I get it is plus infinity, but since I have negative 1, this becomes negative infinity. So the conclusion that x equal negative 2 is a vertical asymptote. Okay, and then I have here y equal 1 is a horizontal asymptote. So I have one horizontal asymptote and one vertical asymptote for the function f. Okay. Right. Any question here? Yes, Ali?
Is there any another way to find the horizontal one?
You're talking about horizontal? No,
Yeah.
I have to do the limit. I have to do the limit. You have to take the limit as x goes to infinity, and another one when you take the limit as x goes to negative infinity. Okay?
Okay. Thanks.
You are welcome. Yes. Any other question? Yes, Ahmed?
Yes, doctor, do we have to check for the step 2, or we just do the factorization and equal it to 0 and get the first?
You can do that. You can do that. Actually, the limit is kind of justification, because if it is a written exam, it is written, then you have to justify yourself by this. But as a quick, the way how we construct it, yes, you can say that x equal negative 2, this is the vertical asymptote. Make sure that this will not make the numerator 0. Okay, will not make the numerator 0. Okay, and by the way, what we did is for a rational function, polynomial or polynomial. If the type of function is different, then I have to be careful. Okay, right. Okay. Next question. Find the equation. So no one asked. Okay. Find the equation of horizontal and vertical asymptote for this curve. Okay, for this curve. And actually, because I'm dealing with the square root, I want to. I have a point there I want to talk about. So yeah, let me maximize this actually.
X plus
bigger. Yes. So first thing, Shabab, I have to do. Let's say horizontal asymptote. Okay. Let's check for the horizontal asymptote, meaning that let's check the limit as x goes to plus infinity of f of x. By the way, Shabab, what is the domain of this function? What is the domain? Yes, Faisal?
x square minus 1 is greater than 0.
Yeah, so I need, greater than 0 means that x squared greater than 1 means that absolute value of x is greater than 1. You know that x greater than 1 or x less than negative 1. So it means that minus infinity to negative 1 union 1 to infinity. Okay. So whenever I take the limit, I have to make sure when I say x goes to plus infinity, it makes sense. Yeah? I don't want to go infinity and the function is not defined there. Okay? So you have to be careful on this one. But this is okay for this function. Okay? So limit as x goes to infinity of 3x minus 2 over square root of x squared minus 1. How to calculate this? If you know, raise your hand. How to calculate this? Yalla, quickly يا شباب. يلا شباب. I'm doing this now. How to calculate? When I go infinity in the numerator, this plus infinity, in the denominator also plus infinity. So I have the case infinity over infinity. Okay, I put a question mark. The numerator is getting bigger and bigger. The denominator is getting bigger and bigger. I don't know who gonna win. So to check, to figure out what you do with Talal. Yes, Talal.
I want to take x square out of the square root, so I'll take a common factor and check if it is positive or negative infinity. I say
Exactly.
negative x.
Very good, ya Talal. So I will take common factors. Okay? I take common factor x from the numerator, so you're left with 3 minus 2 over x. When I take common factor here, I take x squared as a common factor. When you take it out, remember, it should be absolute value of 1 minus 1 over x squared. And then this will be limit as x goes to plus infinity. And then I have to ask myself, what should be the absolute value? Because I have to remove the absolute value, but x, I'm going to plus infinity, means x is positive, so it will be x like this. Okay, and these guys will go. And when x goes to plus infinity, this will goes where يا شباب؟
0.
0. So this will be 3 minus 0 because this is a direct substitution. 1 minus, also this one will go to 0. So we get at the end 3. So now I get one horizontal asymptote, y equal 3. Okay. So y equal 3 is a horizontal asymptote. Fine. I did the limit when x goes to plus infinity. Let's do the limit when x goes to negative infinity of f of x. You will repeat the same steps actually. You will repeat the same steps except here, right? What will differ? It will differ here. You're going to say x minus 3 minus 2 over x, and you get absolute value of x. Absolute value of x, it turns to be, yeah, I think Talal, you want to say the same. It will be minus x.
6.
So we get this. These guys will go, so we have minus 3 minus 0 over 1 minus 0 under the root. So the answer will be negative 3. So y equal negative 3 is a horizontal asymptote. So how many horizontal asymptotes I have? I have 2. I have 2 horizontal asymptotes. Okay. I'm not done. I have to investigate for the vertical asymptotes, and I think it's clear. What are the vertical asymptotes? Huh? If I have f of x equal 3x minus 2 over the root x squared minus 1, I will look for the zeros of the denominator. Okay, the denominator is fine, there is no problem, but I will look for the zeros of the denominator. And what are the zeros, ya shabab? Yes, Talal?
No, I have a question.
Yeah. Okay, let me finish this one. So the zeros are negative 1 and 1, right? Negative 1 and 1. So, and keep in mind, when I put negative 1 here, it makes 0 the denominator, but the denominator will not be 0. When I put x equal 1 in the denominator, it will be 0, but the denominator is not 0. Okay? And hence, we expect the limit will, whenever direction, and be careful, Ishbab, when I take the limit as x approaching, for example, let's say negative 1 of f of x. The limit as x approaching negative 1 of 3x minus 2. I should go from which direction, Ishbab? Should I go from the left or from the right? Or is it okay? I can go from anywhere I want. Yes, yes.
It depends on the domain.
Right. So I go back to the domain. And look at the negative 1. I must go from the left. I must go from the left. So here, I must go from the left. Okay. But anyway, you will get plus or minus infinity at the end, and here you must go from the right. So x equal negative 1 and x equal 1 are vertical asymptotes. طيب طلال, you want to ask? Yes, طلال.
الحين الدومين هل يأثر الفيرتيكال الهوريزونتال اسمتوت ولا بس الفيرتيكال اسمتوت؟
No, in fact, why I wrote the domain, because when I say limit as x goes to infinity, I want to know, does it make sense or not? Maybe this function is not defined when it goes to infinity. For example, if I replaced if I said this is another function, let me call it g of x. If I say 3x minus 2 over 1 minus x squared. Look at here. Huh? When we say limit as x goes to infinity, this is not defined when x greater than 1, right?
Okay.
Okay, so you have to be careful. It doesn't make sense here. Okay, so but here I make sure that domain I'm fine. When I go say x goes to plus infinity, I am okay. I am within the domain of the function. Okay?
So domain I must have infinity or negative infinity.
Yeah, it must be included in the domain of your function. So when you check for the horizontal asymptote. طيب, yes, فارس.
بغيت أسأل بس في الروت اللي أخذت كم فاكتور أخذت x سكوير ولا x؟
No, x square. I took x square out. This, I'm sorry if I was rushing. This is when I took it out, it took out like this.
Okay.
When you know the square root of x squared, it will be absolute value of x.
Okay. طيب بس في الفيرتيكال لما طلعنا الاصفار، لما طلعنا ايه x minus 1 و x 1 should I check ولا خلاص؟
No, no need to check because what? Because why? Because when you put -1 here, just check the numerator. Does it make it 0 or not? If it doesn't make 0, then yes, that's your vertical asymptote. And also for this one, if one of them gave you 0 in the numerator, then you say no. I have to do the limit and I have to figure it out what it will give me. Okay.
Okay. أهم شيء إنه ما يكون يعني في الدينومينيتور وهذا صفرين، صح؟
Yes. I need in the denominator 0, but I don't want it to be 0 in the numerator. Or let's say this: if it made it 0, if it make the numerator 0, then I have to do the limit. I have to see what exactly I will get. Okay. طيب. Next example is this: find the equation of horizontal vertical asymptote. I leave this to you. For the len يا شباب. For the len. Okay. What is the domain of this guy? Just want to make sure when I say limit infinity, is it defined or not defined? Okay. So I have y equal len x plus 1 over x negative 2. So you know that it is from -1 and 2. Okay. When I say x plus 1 here, after -1 it will be positive and negative. Let's say x minus 2. Before 2 is positive and negative. When you combine these two, when you multiply or divide, you say this over this, negative over negative is positive, positive. Okay. So what will be the domain? Or equals, let's say. Okay. Yes, Harris. Minus infinity. -1 union 2 to infinity. Okay. معلش يا شباب يعني I'm rushing quickly. I want to, when I ask your name, just say it right away يعني quickly, because I have to finish all these exercises within this stuff. طيب, so this is the domain of my function. So I can go to infinity, I can go to negative infinity, no problem with that. Okay. So now let's check for horizontal asymptote. When I take the limit as x approaching to plus infinity, let's say, of len of x plus 1 over x minus 2. Okay. Now I have len. Now len is a continuous function on its domain. Yani, just make sure that whatever inside is positive. I'm sure I am positive inside. So I can push the limit inside by saying this. Okay. Of x plus 1 over x minus 2. I can say this, okay, because len is a continuous function on its domain. I am sure inside it will go to give me a positive number or positive infinity. That's fine. Right. What is the limit of polynomial over polynomial? Again, I check the degree. The degree are the same. So it will be the coefficient of this over the coefficient of this. So it means 1 over 1. So len of 1 over 1 over 1 means len 1 means 0. Okay, it means 0. Similarly, when you take the limit as x goes to negative infinity, len of x plus 1 over x minus 2, you take the limit inside and you do the same thing, and you will get also len 1, which is 0. So the conclusion that is y equals 0 is a horizontal asymptote. So you have one horizontal asymptote. طب إيش بقى? What about vertical asymptote? Where should I look for? Okay, so remember this function is not only fraction or rational, but it is more. There is a len involved here, x plus 1 over x minus 2. Okay, what are the things I have to be worried of? Remember, I want the limit when x approaching to whatever number I will pick of len x plus 1 over x minus 1. I need at the end, I need to be plus infinity or minus infinity. Plus or minus infinity at the end.
X minus 2, doctor.
So yes, so when I look at the denominator of this fraction, I see x minus 2. Okay, I see x minus 2. So that means one suspect is when x minus 2 equals 0 means that x equals 2. So when I make this 0, and look here, numerator is not 0. So So what will happen? Okay, let's check here. The limit as x approaching to 2, but here I have to look at the domain. Where should I go? I'm going 2 from the right. Okay, I have to go 2 from the right. I have no option. I have to go 2 from the right. Of len of x plus 1 over x minus 2, which is equal to the len of, when I substitute 2, I will get here 3, and down will be 0, but 0 from where, Ishabel?
Right.
From the right, so it means this one. So it means len of, this is kind of notation I'm gonna use, يعني abuse of notation. Maybe people agree with us, people don't agree with us, but this is plus infinity. Fine. Len of big numbers. When this inside the len gets bigger and bigger, what will happen to the value of the len, Ishabel?
Will be bigger.
Bigger and bigger and bigger. So how we express that? We put plus infinity. Okay. So this is what we have. Wait, is this the only so here we can say, so x equal to is a vertical assembly. So my question here is this: is this the only one?
Yes.
Wait, this is coming from the fraction, this expression, huh? But what about the len? If I graph the len, just in the margin here, you know the graph of the len. X, Y, you know the graph of the len looks like this, right? Here at 1, right? Here. And this is y equal len x. When inside the len gets closer to 0, the graph goes to down, 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 means negative infinity, right? So if I find some value for x that will make this 0 and approaching to 0 from the right, then the len at this one will go to negative infinity, right? Wait, what will make this 0 inside the len if x equal?
Minus 1.
Minus 1. So I have to go minus 1. But of course, I have to be careful. I have to approach minus 1 from where? Look back to the domain. I have to approach it from the left. Okay, from the left. So here, so it means that len of 0, and we put minus 1, so it will be minus 2. And when approach to 0 from minus 1, x plus 1 will be what? 0 from where, Ishabel?
Left.
Yeah, x minus 2. So this will be x, here will be minus 3. Yeah, and here about the 0, Ishabel. From right or left, Ishabel?
Left.
From the left. From the left. Right. When I approach to 0 from the left, Ishabel, I am here. And dividing by the negative 2, what will be, Ishabel? It will be 0 from?
From the right.
From the right. It will change when you divide by negative 2. Whenever number you divide by negative 2, you will reverse the direction and approach to 0 from the right. And according to the graph, when I go close to 0, the graph of the function goes negative infinity. So we have negative infinity like this. So x equal negative 1 is a vertical.
Doctor?
Yes.
X plus 1. 1 from the left plus 1, it will be positive, the numerator.
No, look here. Negative 1, negative 2. What are the numbers here?
Okay, minus 1.1 to
minus 1.1. When you add here, you get negative, right? So, yeah.
Yes.
Yes, okay. So, good. Okay, Shabab. So I have two vertical asymptotes, x equal negative 1, x equal 2. And I have one horizontal, right? One horizontal, two vertical for this function. Okay. Right. Let's move on to next question. Evaluate each limit if exists. Evaluate each limit if they exist. Okay. You do the same thing. First, substitute. If it is, if the value of the expression give you a fixed number, then the answer will be that number. Okay. Even here, even here. If you get 0 over 0, when you substitute, you get 0 over 0, then you have to do factorization. And if there is cancellation, that's it. Do it and substitute. If you get a constant number, do that. If you get over 0, I explained to you how you do in that situation. Okay. What about the number 5, Ishabel? I will solve number 5. the limit as h approaching to 0 from the right. Root 9 plus h minus 3 over root of h minus 5. Okay, what should I do?
Plus 3 to multiply by the conjugate.
Multiply by the conjugate. But remember, Shabab, when I multiply the conjugate, that means I have a problem in the expression. Not every time when I see this, I will multiply the conjugate. Huh? If I have a problem with the expression. Now, what is my problem with the expression? Let's check first. I substitute 0. When I substitute 0, I think Faisal want to say, or what you will get is that?
It should be positive instead of minus in the 3.
No, h approaching to 0 from the right because the root here is defined.
No, I mean in the numerator.
The numerator plus 3.
Plus 3. Yeah, you are right. Okay, plus 3. Okay. Yes, what I want to say, yes. So when h approaching to 0 from the right, when I substitute, I have root 9 plus 0, and then out of the root there is plus 3, and here I have 0 minus 5. And this will give me 3 plus 3 over negative 5, so it means minus 6 over 5. I am done. Alhamdulillah. Why I need conjugate for this one? You see, Shabab? So the conjugate comes into the play if there is a problem in the expression. For example, number 6. This is 5. Number 6. I want to calculate the limit as h approaching to 0. Okay, sorry, here. Root 9 plus h minus 3 over h. Okay. Now, when I substitute in the margin here, I have root of 9 minus 3 over 0. Root 9 means 3 minus 3 means 0 over 0. Here I have a problem. Okay? And whenever I face this problem, 0 over 0, because it's not clear to us, then we have to do something on the expression. If you have a polynomial, we do the factorization as we saw. But if I am dealing with the root, square root like this, then, as your colleague said, I will multiply by the conjugate. Here the conjugate comes into the play. So here the conjugate will be 9 root of 9 plus h plus 3 over the root 9 plus h plus 3. Okay. And then this becomes the limit as h approaching to 0. And you know that, the formula, just to remind you, the a, when you have a minus b times a plus b, this becomes a square minus b square, right? So this is kind of a and b. Huh? This is a minus b, a plus b. So it becomes a square means the root of 9 plus h square minus 3 square. This is what you have. The denominator is just h times the root of 9 plus h plus 3. Okay? This is equals to the limit as h approaching to 0. Now, when you say you have a square of the root, becomes 9 plus h minus 3 square means 9 over h times the root 9 plus h plus 3. This is equals to the limit as h approaching to 0. Now, you see, by the conjugate, it made me cancel these two. So I have h over h times the root 9 plus h plus 3. And also this h will cancel with this h. This is why we need the conjugate. I want to look for the 0, the one that caused me the 0 in the denominator to cancel the 0 in the denominator. So now this made me 0, this made me 0, so it cancels, I have this. Now when I substitute, I will have 1 over the root of 9 plus 3 means that 1 over 6. 1 over 6. Okay. So this is the conjugate idea, the multiplying by the conjugate. Right. The next problem, which is number 7, find the limit of this. Find the limit of this. Basically, it's just the first step. Well, you substitute. Okay. Let me do it here. When you substitute, limit as t approaching to 0, the mouse here, 1 over the 2 root 1 plus 2t minus 1 over t. When I substitute 0, Shabab, I will have 1 over 0 minus 1 over 0. You have things not pleasant, not clear. So we have to do something. What do you think, Shabab? You have to simplify or rewrite the expression to make it more clear to us. So you can feel it. Ahmed Yasser, yes?
Subtract, we multiply the denominator and we see.
Very good. So I have to unify the denominator and combine them together. So what will be the common denominator, Shabab? I have t root t, so that means it will be t root 1 plus t. That means the 1 stays the same. And here I have to multiply.
A t square, sorry.
No need for t square. Okay. For example, when you have a fraction 1 over 3 minus 1 over 6, what will be the common denominator? What is the least common multiplier? Is it 6, right? So it will be minus 1, and here we need to only multiply by 2. Up and down. So it means 2 minus 1, so it means 1 over 6. This is coming from the basic thing about the fractions. Okay, least common multiplier. Okay, so the common denominator is the least common multiplier. Okay, well, if you want to multiply together, that's up to you. You can do that, and it still works. Okay, fine. So here I have 1 minus. Here I need to multiply by the root. What is missing is the root, so it will be like this. And then what is Shabab? Of course, when I substitute 0, when I substitute t equals 0, I will get 0 over 0. I have a question. Now, this is better than dealing with this one, actually. So what I need to do next, yes, Ahmed?
Now we multiply with the conjugate.
Multiply by conjugate. So I leave this. This is clear. I'm repeating the idea as with the previous. So the conjugate will be 1 plus the root. Actually, let me do it, because there is a common mistake between students. Yeah. Let me do it. I'm sorry. Let me do it this way. Yeah. That's why I picked this problem. Yeah. Limit as t approaching to 0. Yeah. What will be here, Shabab? In the denominator is easy. You have this. Yeah. In the numerator, Shabab, what will be? 1
minus
square.
1 minus t.
Yeah. So minus 1. And then let me write the. No, be careful. Yeah. Exactly as you said. So it is originally this, right? This is originally from the formula a minus b times a plus b equal a square minus b square. And then you're going to say limit as t approaching to 0. You're going to say 1 minus, when you open this square, is 1 plus t inside, right? T root 1 plus t, and then the same guys here. And here, as your colleague said, the minus will multiply to the expression. So it will be 1 minus 1 minus t over t root 1 plus t. I don't know if you are seeing this. Yeah, 1 plus root 1 plus. Okay, this guy will go, and I emphasize on this minus, because I'm sure many students, they forget this minus. They will put minus 1 plus t. Okay, so don't forget this. Okay, and the t will cancel with this one, so you're gonna have the result will be negative 1 over 1 times 1 plus 1, so it'll be negative 1 over 2. Okay, negative 1 over 2. Okay, fine. So please be careful when you have the root on the right after the negative. Be careful, everything will change the negative side. Fine. This one, Shabab, I don't know if you've seen this in the lectures, but what is the idea here? When I substitute 1, I get 0 over 0. So I put question mark. Then I have to, since I'm dealing with roots, yes, Abdurrahman?
Multiply by the conjugate of the denominator and numerator.
Okay. Now, actually, very good, Abdurrahman. This is really the solution of this one, but I don't want to spend much time on this one. But the idea that I will multiply the conjugate, let's say the denominator. I'll say 1 plus root x, and here up 1 plus root x. And then I work it out. I will find that I'm still sticking to 0 over 0. Okay, that means, and there are roots involved here. Okay, that means I have to multiply by another conjugate. But in the first place, you cancel the denominator. So that's why we need another conjugate, right? That's why we need another conjugate. So some of you may ask how you thought of 2 conjugates in the beginning. Of course, in the beginning you cannot say this, right, quickly by looking at it. But the idea that 1 conjugate is not enough. When you process and solving, you will find you will stop, and then you have to think of another conjugate. Okay. Right. I'm leaving this to you. I leave this to you because we have a lot of things next to talk about it. But try this. Yeah, dealing with the absolute value. Dealing with the absolute value. Let's calculate this limit. Bring this guy here. The question is evaluate the limit. Okay. Limit as x approaching to 1 from the left, x squared minus absolute value of x minus 1 minus 1 over the absolute value of x minus 1, which is equal to limit as x approaching to 1 from the left. So we have x squared minus, then I have minus 1, and then I have to decide. Now, for the absolute value of x minus 1, now as we know that when x approaching to -1, then x minus 1 will approach, which will be what, Shabab? Positive or negative, Shabab? Here 1, here 0, here 2.
It'll be negative.
Yeah, so it will be negative. So that means so that means it will be minus of x minus 1. If you're gonna see that, it will be minus of minus x minus 1. And down here it will be minus of x minus 1. Okay? Faisal, do you have a question? Okay, fine. So it will be minus, and I have a minus in the original one. So what will be? It will be limit as x approaching to 1 from the left. Down, you can write down here as 1 minus x if you want, or you want to keep it. And then you have x squared. Now minus with minus becomes plus of x minus 1 minus 1. So it means that the limit as x approaching to 1 from the left, this becomes x squared plus x minus 2 over, well, notice, maybe it's better I make it like 1. Why I thought of this? Why I thought of this? Because I'm expecting this will be factorized and it will cancel with this one. So that's why I returned back to this. So here x squared plus x minus 2, this is, as you know, this is x minus 1 times x plus 2. And this will go with this one. So we have the limit as x approaching to 1 from the, and by the way, Shabab, why I thought of factorization? Because when I substitute 1 here, it will be 0, and here it will be also 0, 0 over 0. That's why I thought of factorization. Okay, 1 from the left, so of x plus 2 over -1. So when I substitute 1 here, it will be negative 3. The negative 3. Okay. Okay, Shabab? But really be careful on this. The negative sign and these things. Right. This one. Okay, Shabab. Okay. Well, anyone else? Anyone other than Faisal? The limit as x approaching to 0 from the left of x cubed plus x cosine 2 over x. Yeah, Abdul Malik?
We use the squeeze theorem.
We use a squeeze theorem. Why you thought of this? ليش فكرت فيها? Why you thought of this?
Because the cosine 2 over x will escalate.
Will escalate. Very good. And it is multiple by 0. This thing is bounded. Okay. So when I substitute 0, Shabab, it will be 0 plus 0 means 0. Cosine of 3 over 0, and 0 from the left. But cosine, you know the graph of the cosine, it goes like this, okay, and oscillates. When it goes to negative infinity or plus infinity, it oscillates. It never settles or approach to particular number. It's but oscillating between 1 and -1. You know that. Whenever it oscillates, it's bounded between 1 and -1. But when you multiply by 0, this oscillation, in fact, it gets smaller and smaller and smaller and smaller like this. Okay. But what I draw here is not really precise. It's not scientifically rigorous. Okay, so that means we have to formulate or find a theorem that really make it clear to us. And that theorem here is, as your friend said, squeeze theorem, or some people they call it sandwich theorem. Okay, so how to do the squeeze theorem? Well, first we start with cosine of 2 over x, and you know that this is between 1 and minus 1. Okay, and then when I multiply by this expression, and this expression when x approaching from the left will make it is negative. So you can say this is negative 1, 1, okay, because it will solve the inequality. But sorry, I mean cube plus here, and here we have x cubed plus x. And then when you take the limit as x approaching to 0 from the left for x cubed plus x, which is equal the limit when x approaching to 0 from the left of minus x cubed plus x, which is equal to 0. So the limit as x approaching to 0 from the left of x cubed plus x of cosine 2 over x is equal to 0. Okay, so the limit of this function is 0. Okay, the squeeze theorem is very important, not only in this course, but in the future courses you will see this. Okay. This one is also by squeeze theorem. So you may, and this one, by the way, is different from the slide that I uploaded in Teams. Because in the slide in the Teams you may find here 4. I corrected to 2. Okay. Yes, this is about the piecewise function. It's about the treatment of piecewise functions. How to find the limit and how to find the values to make the limit exist or does not exist. So the question says this: let f of x equal this, a plus x when x is less than -1, x squared when x between -1 and 1 with equal to -1, b minus x if x is greater than or equal to 1. Find all values of a and b such that this limit exists and this limit does not exist. Does not exist. Okay. So how to do this?
I think first you must check the -1 and 1.
You are very good. So you know that in a piecewise function, if every definition is continuous, here this is a line which is a continuum polynomial of degree 1. This is polynomial of degree 2, which is continuous. B minus x is a polynomial regardless of what is the value of b. It is continuous. So each one of them is continuous. Then the suspect that, or the things that possibly will make the function not continuous are these, where the definition of the function changes around. So this x less, when it comes from -1 from the left, it has this definition. When x coming to -1 from the right, it has this definition. So I have two different definitions. So it must be, it may be the function not continuous at -1, and similarly for the 1. So the first statement says we need the limit as x approaching to -1 of f of x exists. Okay, this is the first one. So how to make it exist, Shabab? -1 meaning I'm working in here.
We equal the first equation with -2 and the second equation with -2.
So and it is the idea coming from here, Shabab. It's coming from the fact that the limit exists if the limit from the right of the function is equal to the limit from the left. I know the technique you observe that I substitute here and here and it will give me the result, which is true, but just you need to know that it's coming from the fact of the right hand limit and the left hand limit. Okay, so from the right hand limit, meaning I am here, right? I'm coming to -1 or approaching to -1 from the right, so I substitute -1 here. So this is -1 squared equals. When I'm coming from the left, I am here, so it means I am in this definition. I substitute -1 here, so it will be a minus 1. Okay, so this means that 1 equal a minus 1 means that a is equal 2. Okay, so the value of a that will make the limit, if this limit exists, is a equal 2. Okay, but this is the first one. Now the next one, he said I need the value where the limit. Okay, so we need to find the value, the limit when x approaching to 1 of f of x does not exist. Does not exist. What does it mean? Means that I need the x approaching to 1 from the right. What I need it to be not equal from the left. Okay, I need limit from the right, not equal to the limit of the left. But what does it mean? Means that I substitute here and here, right? So limit 1 from the right, I'm here. So it means b, I substitute 1, so b minus 1. I don't need this to be equal to from the left, meaning that 1 squared, which is 1, right? So it means that I don't need b to be equal to 2. So we need b. What are the values of p, ya shabab? All the real numbers except 2. This is the mathematical notation. B in all real numbers. It can be any real number, but except 2, so that the limit as x approaching to 1 f of x does not exist. Okay. We need this, so the limit does not exist. Okay. It's not one answer, it's infinite answers. You have infinite values of p, but except 2. Okay. Right. The epsilon and delta definition. This is one of the, this is really the concept of the limits. Okay. So the question says this: find a number delta such that if x minus 3 less than delta, then this thing square root, the absolute value of the square root of 2 times the square root of x plus 1 minus 4 less than 0.2. Okay, Shabab. What is the limit? Really, it's coming from the limit as x approaching to. What will be the limit expression for this one?
3.
3 of what? What is the function? 2.
2 root x plus 1 is equal to 4.
Equals to 4. Okay, so it's really coming from this. So the L is 4. The function is 2 root x plus 1, and the A is 3. And he gave you epsilon. Epsilon is 0.2. He fixed epsilon for you. Okay. Now, what we will do? Let me just draw a quick picture of this one. Let's say graph something like this. Let me put it just like a positive graph or whatever, just to get the idea and implement everywhere. But the idea is this: that you have A here, and meaning that when I get approach to A, the function will, the value of the function will approach to L. I'm approaching from down and up as I'm going A from right and left. And the idea is this: that it's kind of challenge. He will tell me, okay, I will challenge you by taking up and down. Okay, here it is L minus epsilon, and here L plus epsilon. Okay, I will challenge you. I will make an interval around L. This is the challenge. I will give you an interval around L, and I challenge you to get an interval around A such that when I go reverse the pictures, take the reverse of the image of the value of the function, when I go back, it stays inside the interval of A here. And the interval must be of radius delta. The interval must be of radius delta. Okay? Radius, I mean half length from A to the end of the interval, from the right and from the left. Okay, so this is the challenge. Right. In order to win this challenge, I have to know first these guys here. Okay. So what is L plus epsilon, which is 4 plus 0.2, which is 4.2. L minus epsilon, which is 4 minus 0.2, so it means 3.8, right? Right. When I go here and I picture down, I will get some value, right? When I go back, reverse the picture, I will picture here, I will get some value down. Let's call this, for example, x1. Let's call this x3. It depends on the order. Of course, the sketch is not accurate. This is not really the function square root. This is actually, it should go this way. Okay, but just general picture of this one. So that means I need to know. Okay, we need to know for what value of x1 of the function will give me 4.2. Okay, and in the here I need to know what value in the interval that when I take the value of the function it will give me 3.8. Okay, so let's check in the left. What is f? F is this guy here. Okay, so it will be root 2 times the root of x1 plus 1 is equal 4.2. When I solve this for x1, I have to divide, right? I have to divide, so it means 2.1. And then when I take a square, x plus 1 equals 2 plus 1 square. And then we do 2 plus 1 square, well, we can do in the margin here. 1, 2, 2, 4, 4, 4, 1, and then I have to go like this. So it will be this, right? And then this implies that, okay, I should say this, implies that, implies that, implies that x1 is equal, I move 1 to the side will be negative, so it will be 3.41. Right, شباب? طيب, I do the same thing here. This implies that 2 root x2 plus 1 equal 3.8. Okay. And then this implies that a root x2 plus 1 equal, when I divide by 2, it will be 1.9, right? And I could get this one. And then x2 plus 1 equal 1.9 square. And then I have to do again, sorry, 18917 and then 91, and then this will be 1, this will be 1, 6, right? 3, right? So it will be like this. So this implies that x2 is equal, I don't know if you are seeing here, yes, when we get negative 2, 6, 1. Okay, remember, Ishbab, the A is this. It should be one of them after the A and the other one before the A. One of them after and before. And really, 2.61 is before the A, 3.41 is after the A. It should be like this. Otherwise, you just make sure of your calculations. Maybe you did mistake or something. طيب, next يا شباب. I am here يا شباب. Now I am here. I found x2 and x1. Okay. Remember, I am in this interval. The A, and here I have x2 and x1. I am in the x-axis now. So A is 3. So 3.41 is here. This is the x1. And here I have x2, which is 2.61, right? طيب يا شباب. I need to pick an interval. I cannot say interval from 2.61 to 3.41. I need to pick the radius. I'm saying radius because really the interval, we can view them as a circle of one dimension. Okay? So which radius I will take? Well, I have to take the difference here. I have to measure the length here. So I will call it delta 1, which is equal to 3.41 minus 3, which is equal 0.41. And delta 2 will be this length, and this length will be calculated as 3 minus 2.61, and this will be 0.93, right? Okay, Shabab. Now, which one I will pick?
The smallest.
The smallest. So the delta will be the minimum of delta 1 and delta 2, which is the minimum of 0.41 and 0.39. So it means that the smallest one, as you know, is 0.39. And this is your data. This is your data. Okay. But I explained it in through the solution, or the way of the solution, from the ideas, if it is coming from the graph. Maybe in the lecture you saw another way of dealing with inequalities and so on. I'm not gonna say it here, but you may also view that one. I mean, it can be solved in 2 methods. Yeah. Okay, it can be solved in two methods. But still, we are getting here. We're getting the same. The minimum value is 0.39. Okay. This is about the epsilon delta definition. The discontinuities, Shabab. I'm in the section of continuous function. Sorry, if I might take 10 minutes to finish the part of the continuity. Okay. Now, the definition of the continuous. Before I solve that question, let's revise ourselves. F is continuous at x equal a if what is about? If the limit as x approaching to a if f of x equals f of x. So this is the definition of the continuity. The function, the limit must exist, and the value of the limit is equal to the value of function at a, meaning the function is defined at a. We have discontinuities. Okay, we have actually three types of discontinuities. Number one, we have what we call removable discontinuity. When I will say x, the function has a removable discontinuity at a, if the limit as x approaching to a of f of x exists, but what is it?
But there is, but it's not defined.
But either f is not defined at x equal a, or the value of the limit is not equal to the value. Maybe it could be defined at a, but the value of the function is not equal to the limit. Okay, so this is, we call it removable discontinuity. طيب يا شباب, jump discontinuity. Okay. Number two, jump discontinuity. We say that the function has a jump discontinuity at a if the limit as x approaching to a from the right, let's say f of x, is not equal to the limit as x approaching to a from the left. Okay. By the way, each limit exists. Each limit exists, but the values are not equal. Regardless of the function f, maybe defined, maybe not defined, I don't care. I would care about the limits left or right, so to call it jump discontinuity. And the last one is infinite discontinuity. If what is about this, if the limit as x approaching to a of f of x is equal plus or minus infinity. Okay, plus or minus infinity. So I will say the function has infinite discontinuity at a, regardless whether the function is defined or not defined. I don't care. The limit, I have this limit, خلاص, I will say infinite discontinuity. طيب sure. Now look at the question. Is the function f continuous at a and b? What type of discontinuity if it is not? The first function I have is the greatest, actually the function is piecewise. Okay, so we have first one is the greatest integer function of x, if -2 less than x less than -1, and then we have x plus 1 if -1 less than or equal x less than 2, and then we have 5x minus 7 if x greater than 2. Okay, and he said please check with a -1 and -2. Okay, طيب يا شباب, let's check when -1. This is -1, I am here. Okay, طيب يا شباب. Now from the left I have this definition, from the right I have this definition. What I need to check is what? I need to check the limit and the value of the function. So what is f at -1? Let's start with this one. What is f at -1?
0.
So I substitute -1 plus 1 means 0. I substitute here. Very good. طيب. Notice I am piecewise function. That means when I say limit, it's not, I have to split it into two limits. Limits from the left, limit from the right. Okay. So when I take the limit as x approaching to -1 from the left of f of x, it is basically taking the limit as x approaching from the left. What will be the definition of the function? I am from the left. It should be this definition, which is the greatest integer of x. Now, about the greatest integer function, let's draw real numbers here. This is -1, this is 0, this is -2, and here 0. Okay. Right. Where am I? I'm here. Each number is -1 point something. What will be the greatest integer of these numbers?
-2.
It will be the first integer on the left. My first integer on the left is -2, so this will be -2. Okay. Right. When I take the limit as x approaching -1 from the right of f of x, it will be the limit as x approaching -1 from the right. It should be this definition, which is equal to 0, which is equal to the value of the function here, right? But no, look here, Shabab, the limit here is not equal the limit here, right?
It jump.
So we have, so f has a jump discontinuity at a equal -1. Okay. Now this is when a equal -1. Now let's check when 2. Okay, let's check when 2. Okay. When t is equal to. Now this is the 2. Here and here. Okay. So when I take the limit as x approaching to 2 from the left of f of x, which is equal to the limit as x approaching to 2 from the left, what will be the definition? It will be this, right? I have to work with this one. And when I substitute 2, it will be 3. So I take the limit when x approaching to 2 from the right of the function f, which is equal to the limit as x approaching to 2 from the right. So I have to take this definition, 5x minus 7. It will be 10 minus 7. It will be 3. So now the limit as x approaching to 2 of f of x, because these are equal, the limit, it will be 3. So can we say the function is continuous, Shabab?
No.
Why?
Because it doesn't equal. It's still not defined that point.
Aywa, notice that f is not defined when x equals 2. So what will be the conclusion, Shabab?
Removable discontinuity.
It has removable t equal to, or you can say x equal to. Okay? Removable discontinuity. Awesome. F has removable discontinuity at t equals to. Okay? Yes, Ali?
Doctor, if the left-hand side and the right-hand side is not equal, it's a jump. And if it's equal, it's removable. Okay, what about the infinity?
No. Be careful. If they are equal and the function is not defined, or the value of the function is not equal to the limit, then we say removable. Huh? This is not enough. This is not enough to say removable. Huh? Just I want to correct what you said here. This is not enough to say removable. This and the function is not defined, or it could be defined, but the value of function is different from this limit 3, for example. Okay? Fine. Now, the second part of your question, infinite means when you take the limit, you will find equal infinity. For example, when you have 1 over x, 1 over x plus 1. If this is 1 over x plus 1, when you approach to -1 from the right, it will give you infinity, right? Minus or plus infinity. Okay, Ali?
Yep.
Okay. Find the values of k so that the function has a removable discontinuity. I leave this for you. Find the values where the function is continuous everywhere. I think the trick is clear. It's famous to students how to do that. And about the intermediate value theorem, and so on. I leave this question for you because the time is not allowed. But let me talk about the derivative, because so far I did not do anything about the derivative. Now, how to solve this question? And I will stop here. For this question, I'll stop. The graph of the function f is given below. You have this graph of the function. But he did not give me the rule, the definition of the function. And he asked me to calculate this, f prime at 0 plus the limit as x approaching to 2 from the right 4 times f of x equals. Okay. Now, I will. This one we already talked about it. I mean, actually, we did not talk it really, but what you will do basically, you will follow. This is the 2 here, right? This is the point 2 and 5, meaning you are here. Here, this is 2. Okay. So I am approaching to 2 from the right. Okay, and I have a constant. Know that the constant will stay, right? Will stay here. 4 times what, Shabab? I have to follow the function. So it will be
5.
So this part is easy from the graph. Okay. Right. What about the derivative, Shabab? F prime at 0. This is 0. So what does it mean, F prime?
gonna find the slope of the line?
In fact, the derivative is the slope of the tangent line, okay? It's the slope of the tangent line of this curve. But since the curve itself is a line, then the tangent line is the same as the line of the curve, right? Or the curve itself, okay? So that means I have to find the slope of this line. How to find the slope of this line? Well, this is a really basic thing. The coordinate of this point is what, Shabab? Is 0, -3. And the coordinate of this point is -3 and 0. You have to pick 2 points on the line, which I picked these 2 because he gave me. Or you can pick this point also, it's fine. And then you have to do the ratio thing, right? Then you have to say what? Who gonna remind us?
Delta y over delta x.
Delta y over delta x. So for example, you can say 0 minus -3. Okay, I'm subtracting this direction. 0 minus, and then you're gonna say -3 minus 0. Okay. So this will give us 3 over -3 means -1 plus 4 times 5, which is 20. And this will be 19, which is the first answer. Okay. طيب يا شباب. The time, I'm sorry I'm exceeding 10 minutes more for the time, but you have the slides and you can solve these questions. And thank you again for coming to this session, and I wish you all the best for your major exam for Math 101. سبحانك اللهم وبحمدك أشهد أن لا إله إلا أنت أستغفرك وأتوب إليك.